I've already gone over these, but when you have the same base, then life is easy. 2 to the x, 8 to the x minus 4. You would just replace this 8 with a 2 to the what? 2 to the third. That way you got the same base. And then this just has to equal that. All right. Next up, different bases. What if it's 2 to the x, and I'll make it ridiculous, 1.6 to the x minus 4. You're not going to make those bases the same. So what are you going to do? We forget so quickly. Going to put an ln in on both sides. Write that one down because you didn't remember what to do, so write it down. You're putting in an ln 2 to the x equals ln 1.6 to the x minus 4. Some people haven't written it yet, so we're still waiting. The reason I can tell is if your hand hasn't moved. You can fake it pretty well if you just drew pictures all out, right? You never know. Unless I walked over and checked. Marcus, you got this written? Yes or no? Okay, hurry up. So now we have ln of 2x equals ln of 1.6 to the x minus 4. Why did we do that? Wait, 2 to the x, sorry. 2 to the x. Why did we do that? Yes?
Because then we can put the exponents.
Because that's exactly it. Because then we can put these down out of exponent spot to in front. And we're not even going to do it. I'm just reminding you that that's how you would do it. Okay. Hidden quadratics. That's where in the middle of a problem, we'll have one of those in the problems today. You're going to kind of clear out the logs and all of a sudden you're left with a quadratic. Remember that quadratics have to be set equal to 0. And then if you can factor it, you should. And if you do have one that won't factor, you could graph it, but there's no graphing calculators in this next test, so that's out. Or you could solve a quadratic by using the quadratic formula. Okay, good. Next up, we need to look at a few where there's just like logs on both sides. Well, I have good news for you. You can bring them in and you can also just take them out. You get it's that easy. Now I have 2x minus 1 equals 11, and if you can't solve that, game over. All right, how about this one? Can I take those logs out? Yes, I can. And x squared has to equal x. That seems weird. Does that seem impossible to you, though? No. If I was going to graph those, I can graph them in my head. Y equals x squared. Boom. Y equals x. Boom. And it makes me feel like they would touch at least once at 1, 1. Oh, and 0, 0. So see how I knew the answers? 0, 0, and 1, 1. Could I solve it another way? Sure, it's a quadratic. X squared equals x. Well, what did I say about quadratics? How do you always solve them? Graph them, which I just did, or set them equal to 0. So I would subtract x from both sides, and that's x squared minus x equals 0. And if you can factor it, you should. 0 and 1. All right, Vivian, that goes in your backpack. Please don't take it out again. All right, next up is, how do you solve this one? You can't take the logs out. You can't put logs in. It's already got a log. So my first step is, can you factor it? Can you factor it? No. Can you clear fractions? No. Then in this unit, what are you supposed to look for? Rewrite it. Everybody rewrite number 1 there on this page. Two to the 4th, I call it the circle of logs because it has to go around like that, equals x plus 5. And then, what is 2 to the 4th? 16. So 16 equals x plus 5. Subtract 5 and you got 11. Raise your hand if you beat me to that. Okay, cool. How about this one then? I want to just be quiet for a minute. And no, it's not no solution because there's a negative. No, you just have to, your x values that you'd put in would have to be negative, and then you'd be okay. I get how people think that, oh, this one doesn't have solutions because there's a negative inside. No, it just means that your x values need to be like negative themselves. Like if I put in -4, you'd be fine. All right, so don't think that there's no solution. There is. Can you rewrite it right this second? No, you got to do something first. Mr. Brahma, what do you suspect we do first? It is. I will do what I told you, which was to rewrite that as a log base e. I like that. That is a good thing to do first. What's a good thing to do second then? Yes, you would. Because now, if we add 5 to both sides, then it's 3 log base e of negative x is equal to 15. Now I can rewrite it. Nope.
You could divide it with 3.
I have 2 things I could do with the 3. I'd like you to process that for a second. Yeah, I could divide by 3, but what else could I do with that 3? Could put it as an exponent right there, but I'm going to warn you, if I do that, then later I'm going to have to take a third root of something to get it off of there. So yeah, it can be done, but it's not really the smart thing to do. Smart thing to do, divide by 3. Log base e negative x equals 5. Now can I rewrite? Yes. Charlie, give me the rewrite on this one.
E to the 5th power equals negative.
Yep. Is x completely alone yet? No. Asher, last step.
You divide by -1 on each side.
Absolutely. Times by -1 would have worked as well. And I got negative e to the 5th equals x. Make sense? Okay. This page. Well, I don't want to put in logs. I can't take out the logs because there isn't logs on both sides. I could go add that one log to get it on the other side, but then there'd still be the 1 there. So I can't just make the logs cancel. Whenever you have 2 logs, you must condense it down to 1. Everybody condense that and then solve this. Practice condense a lot. I'm going to say that most of the people that didn't turn in their homework were people that were absent. So it makes sense to me that, you wouldn't turn in your homework if you're absent. But there's a few people that didn't turn in their homework last night. Just get it done. It was a Schoology quiz, and then there was also a few other problems. But for right now, I'm talking about the Schoology quiz because I can see who hasn't turned those in. Also, for attendance purposes, okay, let's see if you got log base 3 of x over x minus 5 is equal to 1. Please tell me you thought of rewriting. Who thought of rewriting and did? Okay, good. 3 to the 1, which is just 3, equals x over x minus 5. I better put the to the 1 there so anybody following at home doesn't get lost. That was a rewrite. Now, how do you solve that? Well, do you remember? Yes. Yes, you are clearing the fractions. My number 2 suggestion. My number 1's always factoring. It's not because I think factoring happens all the time. It's because factoring is the thing nobody looks for. Because we've had so many times and everybody stumped, and it turned out you just had to factor it. Clearing the fractions happens a lot, though. 3x minus 15 equals x, and then again, if you can't solve it from there, you're in big trouble in this class. All right, on to this one. This will be very similar. Go ahead and solve this one. So here, I hope you knew right away to combine these two together. That's what we learned condense for. Log of 5x times x minus 1. Why times? Because that was plus. That's why this is times right there. Okay, equals 2. And then I don't see a base, so then that is a critical element. It'll be all about the base. So 10 to the 2, which I would know is 100, I hope you would too, is equal to 5x times x minus 1. Look at that, there was a quadratic hidden in there. 100 equals 5x squared minus 5x. Subtract 100 from both sides. 5x squared minus 5x minus 100. If you can factor it, you should. Has anybody already found it? 3 people. All right, then I want you to all take a minute. 3 people have found it. We know that it exists. Please factor that. That is a typical test question. We usually make them factor because the solve by graphing way isn't usually an option because you don't have the graphing calculator. So I'm going to pause for a sec while everybody factors that. How many of you got it factored now? Raise your hand if you do. All right, Matthew, tell me how to start. Excellent, I like that idea. 5 comes out. And then I have x squared minus x minus 20. And then what'd you do? Perfect. You have found 4 things by doing that. 5 and negative 4 are, name one of the 4 things they are. X-intercepts, give me another one. Give me another one. And what's the last one? It's anybody. Yes? Solutions. There's 4 names for those. We could say find the solutions, find the x-intercepts, find the roots, or find the zeros. Okay. All right, so a few more examples. Well, this looks weirder. Do you remember me yesterday saying, what if you had a really complicated problem, you could make it easier by swapping in a certain letter? Do you remember that? What letter? U. So we say let U equal, and what's the thing you see that appears more than once and is kind of complicated, Mr. T? Log base 2 of x. So wherever I see that, I can replace it with a u now. I got u squared plus 20 equals negative 9u. And then you just act like that's your problem. Because we pulled out the log base 2 of x and we put in a u. Solve it, everybody. In a moment, I'm going to ask you to compare your final answer with the other kid. Remember at the end, you have to swap the log u, or the log back out for the u. So the u comes out and the log comes back in. I want you to do 1 and 2, and I would like you to work with the person next to you. I'm going to form those groups right now. Okay, so I get down to here, and if you have u's in your answer, you aren't done. Because you should only use u substitution when you're doing a substitution. That'll remind you to get the u out of there. And the u gets replaced by the log base 2 of x. Can a log base 2 equal a negative? Yes, it can. Think about that. Do you get that you don't have to have positive numbers here? Okay, So then the final answer is 2 to the negative fifth equals x. X equals 2 to the negative fifth. And that's some very small number. Because 2 to the fifth would be a very big number, and then it's negative, so it's 1 over that. And the other answer is log base 2 of x equals negative 4, so 2 to the negative fourth equals x. So there's your two answers. Raise your hand if you had those right. Okay, awesome. Do you get how U substitution has come in handy? Expect to see that again. Next, log base 125. That to me immediately says, can I put in logs? No. Can I take out the logs? No. So then I got to think about rewriting it. 125 to the 1/3, that's one you should have memorized. Third root of 125 is like the cube root of 125, which is 5. Equals 3x minus 2 over 2x plus 3. Again, that's just 5. And then I'm going to clear out my denominator by multiplying by 2x plus 3 on both sides. And that cancels that. 10x plus 15 equals 3x minus 2. I'm subtracting 3x from both sides. And now I have 7x plus 15 equals negative 2. 7x equals, I'm subtracting 15 from both sides, negative 17 over 7. I think I'm right. Raise your hand if you got the same thing. Yay. Okay. Get how those were intense but doable? Okay. I'd say that's the same thing about your next test. Here is your assignment, and we have some problems that are a lot like what you just did. And honestly, all of these are good practice. I don't think we need all of them to make it a good assignment, though. So I'm going to skip number 4. On the next page, this is U substitution land. I'd like you to skip these two. I think that the last two are good. Then in here, it's good to have an ln every now and then, so we're doing that first one. But I feel like this is a complete repeat. Same with that. And you can get rid of all those too. Okay, just the first one there on that orange page. And that's it. Get them done. That's all I have for you for today.